Hello everyone. Let us discuss things on solutions for the wave equations. Relationship between electromagnetic fields and source distributions are obtained using Maxwell's equations. All EM field problems are solved using Maxwell's equations. From the knowledge of charge and current distributions, the non-homogeneous wave equations are first solved. Non-homogeneous wave equations, what do they refer to? Del squared A minus mu epsilon dou squared A divided by dou T squared is equal to minus mu J. Is the first non-homogeneous wave equations. The second one is in terms of scalar potential, del squared V minus mu epsilon into dou squared V divided by dou T squared is equal to minus rho V by epsilon. So non-homogeneous wave equations are solved with the help of the knowledge of rho V and J. Once they are solved with the knowledge of A and V, the fields such as E and B can be obtained, or information about E and H can be obtained. So let us solve wave equations for potentials first. Consider an elemental charge, point charge. Q is equal to rho V of T del V at time T. Right. Located at the origin of a spherical coordinate system. Spherical coordinate system. This assumption is very important. We shall start from this equation. Due to spherical symmetry, the scalar electric potential V depends only on R and T. It does not depend on theta and phi. To obtain far field expressions, let us replace small r by capital R. So, the scalar potential in spherical coordinate system satisfying the homogeneous equation 1 by r squared dou by dou r of r squared into dou v by dou r into r squared minus mu epsilon dou squared v by dou t squared is equal to 0. Another important assumption is let v of r comma t be the scalar function. The scalar function is assumed to be of this format: 1 by r u of r comma t. So let us substitute this assumption into the scalar homogeneous wave equations, and then let us solve that equation. Upon solving, we may have to arrive at the solution u of r comma t is equal to is a function of t minus r by square root of mu epsilon. It's a function of t r mu epsilon, square root of mu epsilon. So this expression indicates that the wave is traveling in the direction indicated by r with the velocity 1 divided by square root of mu epsilon. So this is an important relationship based on the assumption v of r comma t is 1 by r into u of r comma t. Substituting this into the homogeneous equation, solving homogeneous equation, we shall arrive at relationship. Right. So what do you understand from this u of r comma t? It's a function of t minus r into square root of mu epsilon. What is it? This equation indicates that the wave is traveling in positive r direction with velocity 1 by square root of mu epsilon. Velocity 1 by square root of mu epsilon. The function u may be modified in accordance with the requirement. Sometimes it is computed as at r comma t. Sometimes it is computed as r plus del r comma t plus del t. So what will happen if I start evaluating at some other point after some time? You can find that it will become, instead of f of t, it will become t plus del t minus r into square root of mu epsilon. This time it is r plus del r into square root of mu epsilon. Good. Because you know very clearly that u of r comma t is f of t minus r into square root of mu epsilon. If so, u of r plus del r comma t plus del t will become proportionately modified equation. So let me analyze this. The function retains its form if, which function? The function retains its form if del t is equal to del r into square root of mu epsilon. That is del r divided by u. What is u? U is 1 by square root of mu epsilon. What is this? This denotes the velocity of wave propagation. Yes. So therefore, v of r comma t is taken as 1 by r into u of r comma t, where u of r comma t has been identified as f of t minus r by u. Right? U of r comma t is replaced by this. So, having known v of r comma t,
I'm not able to read notifications on Mac.
so del v put it in this way, v of r comma t. So del v of r comma t is equal to 1 by r into del f of t minus r by u. So having known all these functions, for a point charge q is equal to rho v of t into del v at the origin of a spherical coordinate system, the scalar function is represented by del v of r is equal to q divided by 4 pi epsilon naught into r, and q is equal to rho v del v. Q is equal to rho v of t into del v. So you can find out what is del f of T minus R by U. It is simply rho V of T minus R by U into del V divided by 4 pi epsilon naught. Right? Del V of R is modified as del V of R comma T. You can just compare. In the place of 1 by R, here also 1 by R is available. What is the extra matter? Rho V of T into del V divided by 4 pi epsilon naught is supposed to be del F of T minus R by U. So now this is a function of not only T, also a function of R by U. So del F of T minus R by U is equal to rho V of T minus R by U into del V divided by 4 pi epsilon naught. So del V of R comma T is equal to rho V of T minus R by U into del V divided by 4 pi epsilon naught R. When you consider the effects of all charges by integrating this equation over a volume V of R comma T is equal to 1 by 4 pi epsilon naught into volume integral of rho V of T minus R by U into del V. Del V with respect to integration, this will become dV, isn't it? Del V divided by R. So V of R comma T. What is this equation? This equation gives me scalar potential V at a distance R from the source at T, which depends on the charge density, but charge density at an earlier time. What is that earlier time? It is not at T itself. It is T minus R by U, which is actually delayed by some time. So delayed time should also be taken into account. What is the amount of delay? R by U. The potentials with which delayed time or retarded time is taken into account is known as delayed potential or retarded potential. They are called in the name of retarded potentials. Shall I repeat? V of R comma T is equal to 1 by 4 pi epsilon naught volume integral of rho V of T minus R by U divided by R into dV stands for retarded potential because it takes the delay time R by U into account. Similarly, the solution for wave equations, for non-homogeneous wave equations for vector magnetic potential is obtained from A of R comma T is equal to mu divided by 4 pi or mu naught divided by 4 pi. Volume integral of J is the current source, volume current source, which is responsible for the generation of A. J of T minus R by U divided by R into dV. Okay. You can just compare. How do you identify the scalar potential, electric potential and magnetic vector potential? Using delay time effects also. E and H are called retarded fields. Retarded fields are retarded because they are generated from retarded potentials, right? So obviously we need to consider the delay time for the calculation of E and H also. So from A and V, by differentiation, E and H are calculated. So those two fields generated from retarded potentials will be called as retarded fields in real time. EM wave takes into account some time to travel, and the effect of time varying charges and currents is experienced only at distance points. After some delay, so the delayed time or the retardation is given by not the original time, it is delayed by R by U. What is R? R is the absolute difference between R and R dash, where R is the coordinates corresponding to source point, whereas R dash is actually the point of observation point. So the distance between the source point and the observation point, modulus of R minus R dash, capital R, is considered for the calculation of delayed vector potentials or delayed electromagnetic fields. Do you know what is meant by U? U is 1 by square root of mu epsilon, and it is the velocity of propagation, velocity of wave propagation. Do you know one thing? For the free space, or I would say the usual atmospheric condition, free space, you can say the velocity of electromagnetic wave is the velocity of light, which is equal to 3 into 10 power 8 meter per second. So you can find out that U is equal to 1 divided by square root of mu naught epsilon naught for free space is equal to 3 into 10 power 8 meter per second. So with which the solutions for the wave equations, non-homogeneous wave equations, are obtained. Thank you.